So welcome everybody to NativeScript Developer Day. If you can't tell by the slide, this first session is all about NativeScript 101. So it's completely an introductory session to NativeScript. If at any point you feel like you're in the wrong session, in the wrong class, feel free to get up and leave. I know Jen's doing a great talk on, what is she doing again? I already forget, but it's something probably better than this. So I won't be too terribly offended if you have to leave. If this turns into some kind of dumpster fire too, feel free. You know, I have a pretty good ego going for me. So my name is Rob Lauer. I help manage the mobility wing of our developer relations team that is about 99% focused on NativeScript. So I'm happy to be here, happy to talk to y'all. And what are we going to cover today? We're going to talk about NativeScript. We're going to talk about what it means, what JavaScript native means, who the big players are, why it's a thing, why you should really even care. We're going to do a high-level introduction to NativeScript. We're going to dive into some of those core concepts and do kind of a little mini Hello World session as well. So for some of you, I realize this will be some review. For others, it'll be new. So hopefully it's useful for all of y'all. So let's start with this existential question of why we are here. How did really NativeScript come to be over the last few years? Well, we've all seen this slide 100 times before, right? We're all trying to get a cross-platform experience on all these devices. And today we live in this world of silos, of course. You know, if we're developing for iOS, we're using Objective-C or Swift. On Android, it's Java. On Windows, it's .NET and such. But what about cross-platform? How do we achieve this cross-platform utopia? And when it comes to cross-platform apps, of course, the default is the web. And, we love the web. Everything we do is based on the web these days. And I love everything that the mobile web represents, especially with the way progressive web apps are coming. But eventually, we need features, we need experiences that the mobile web can't provide, right? We need that native performance, the native experience. So looking at hybrid in particular, by hybrid I mean Apache Cordova, hybrid's really the reason that this family of JavaScript native frameworks exists today. And I've been involved in the hybrid approach for a long time. The hybrid model really preaches this 100% reuse of your web skills, right? Which is amazing, right? It also preaches this 100% reuse of or access to native device features, which is also awesome. Now, this allows you to get access to features that aren't necessarily available with the mobile web. So, at the end of the day, while this sounds awesome, you're kind of left with some compromises, right? Compromises based on performance and other web view-based issues that you have to deal with. Now, we believe that hybrid really has the right ideas, but maybe not just the best implementation. So to achieve this cross-platform utopia, right, we have a few options. We have the mobile web, right? We have PWAs, progressive web apps, right? This kind of natural evolution of where the mobile web is heading. And we have hybrid, Apache Cordova again. And we have native, and granted, true native doesn't have much of a cross-platform story, but if you're willing to put in the grunt work, it's there. We also have what I call first-generation cross-platform native. Now, these are the Xamarins, the Appcelrators of the world, who let you use C# or JavaScript respectively to get that cross-compile solution for cross-platform native. Now, the cool thing is if we take out those first-generation JavaScript or first-generation cross-platform solutions, today we have solutions that are all based on the web, right? Mobile web, hybrid, and now native, that are all based on web technology. But really, if you're developing a mobile app with raw web skills, we kind of think we have a binary choice today, right? If we're going to go hybrid, we get to market quickly because we're using those web skills and we're creating cross-platform apps from one code base. But we're compromising on that user experience, right? List views are really slow. It kind of gives janky animation performance. Or we can go native and give you that best experience, but it's slow because we're developing one platform at a time. And of course, you may think I'm hating on hybrid, and I am a little bit. But the fact of the matter is customers agree. When we survey them, we see that about 84% people say that mobile app performance is either very or somewhat important to them. And more importantly, what do? If the app isn't performant, they're less likely to use the app and they're likely to switch to a competitor's app. So performance is a legitimate concern. So surprise, surprise, I'm here to propose that when it comes to using web skills, it's not a binary choice anymore. Hence this family of native JavaScript frameworks that do let you get fast to market, give you that best experience, everybody's happy. So what is JavaScript-driven native? At its core, it is native UI that's driven by JavaScript. And all the frameworks we're going to talk about here briefly, they all have the same idea, where there's a JavaScript engine that's accessed on the device, and there's a bridge to native UI. And they all have some kind of code sharing in them. It varies a little bit. Let's briefly talk about the biggest players here. Certainly React Native from Facebook is a huge player, and NativeScript by us at Progress. Three of the smaller players you should just know about, have in the back of your mind. Weeks is a product from Alibaba. It's very focused on the Vue framework. There's also Fuse Tools. It's a startup in Scandinavia, very design-focused, cross-platform framework. There's also Flutter from Google, which, being that they're from Google, you think they'd be pretty interesting. The problem with Flutter, though, is that you have to use Dart, and nobody really wants to use Dart, so it's kind of languishing a little bit. But focusing on the two big players, NativeScript and React Native. Now, both effectively work the same way. You're writing JavaScript. It's running in the JavaScript VM on the device. It's leveraging native UI. These are not cross-compile, right? It's actually executing JavaScript on the device. I'd say the biggest difference between the two, or one of the big differences, is that NativeScript is focused on writing once by default, whereas React Native is more focused on learning it once and then writing for each platform. Just two different ways to look at it. Some other differences really quickly here. Plugins, so the way to extend your app with NativeScript, those are written with JavaScript or TypeScript. With React Native, plugins are written with native code. With NativeScript, you can use Angular or not. It's optional. React Native is limited to React support, which I don't mean limited as a bad thing. React's obviously very popular. With NativeScript, we do provide that 100% day zero API access. What does that mean? Well, if Apple surprises us with iOS 12 in 2 weeks, with NativeScript, you can actually leverage those new API features on day one. With React Native, you do have to wait for those native modules to be updated, to be written to access those new API features. The threading model is different between NativeScript and React Native. NativeScript is single-threaded, so everything runs on the UI thread. I put an asterisk on there because there is this concept of service workers, background workers, similar to the web implementation. So when you do need a multi-threaded app, you can get access to that functionality. React Native runs a UI thread and JavaScript on the JavaScript thread. Now, if you got 20 React Native engineers in the room with 20 NativeScript engineers, they could argue about which one's better. At the end of the day, performance is pretty similar. It's still native UI powered by JavaScript. There's certainly going to be situations where one is faster than the other, but in general, they're both pretty performant. So I'm always asked, and granted this conference is focused on NativeScript, but I am always asked which should I choose. Obviously, I'm very biased, but if I'm pressed to give my opinion here or my analysis, at the end of the day, it comes down to if you want to use a framework like Angular, Vue, or just want to use vanilla JavaScript, if you're like a spaghetti code person like me, NativeScript is the way to go. If you're a React person, you're probably going to be more comfortable with React Native. No surprise there. Progress versus Facebook. Facebook, everybody knows Facebook. They have a pretty strong history with open source, except for the whole parse debacle. But Progress, NativeScript is actually a key component of Progress's mobility strategy going forward. So it's really core to us. Is React Native core to Facebook? Maybe, maybe not. I don't know. The licensing is a little bit different. NativeScript and React Native, they're both licensed under very permissive Apache 2 versus BSD. Of course, Facebook went ahead and added a clause to their BSD license, which makes it slightly less friendly for startups, for corporations to use. Yeah, I don't want to spread too much ill will, but it's not the most friendly license. So I'm gonna choose NativeScript today. I suppose you don't want to hear a React Native talk, so let's focus on NativeScript today. What do you get out of NativeScript? Fast to market. Well, you are sharing code between platforms, right? iOS and Android. You are leveraging those existing skills and teams. So you're using your web skills, of course, to develop native mobile apps. And you're using existing libraries. I'm going to touch on this quite a bit, where you can take existing JavaScript libraries, CocoaPods, Android jars you find, and you can drop them in your NativeScript app and just use them. And in terms of the best experience, well, you are leveraging native UI. There's no web views here at all. This is not hybrid. This is not Cordova. This isn't PhoneGap. And you do get full access to those device APIs, which means immediate access to new OS features. So intro to NativeScript, what is it? How does it work? Oh yeah, anyone ever notice how young Christopher Walken looks just like Scarlett Johansson? I just love this picture, I had to share it, sorry. So project timeline, so Todd already shared some of this, but just to kind of recap, we did start this back in 2013 with some early prototyping ideas. Is this crazy idea really gonna work? Turns out it did. So 2014 was focused on building that foundation of NativeScript, whereas 2015, we did the public launch 1.0. Since then, it's been all about adoption, right? Let's improve the framework, let's make it feature complete, let's make it performant, and I think we're there today. Now to prove out this adoption, of course, one public metric we use are NPM downloads, and Todd mentioned this as well. NPM downloads, it's always kind of a black box. You don't know how much you can really trust it, but what we're looking for are trends, and are we heading up and to the right? Yes, we are, so that's a good thing. And we also, of course, track our NPM downloads versus our competitors. Now, when you look at two of the big competitors, Ionic and React Native, Ionic is still king here, which is no surprise. They're the most mature. They've been around the longest. But you can see React Native and NativeScript eating into that as we go. And again, NPM downloads get kind of crazy. You can have one CI server doing 1 million downloads in a day, and it kind of screws everything up. But again, we're just looking for trends here. So what is NativeScript? It is an open source framework, Apache v2 licensed. You are creating native mobile apps for both iOS and Android. You are using your web skills, which means JavaScript, CSS, and an XML-based markup language. You are writing once and running everywhere. We do propose that you can get 100% code sharing between iOS and Android. Now, is your mileage going to vary? Yes, of course it will. For a small app, absolutely. You can get 100% code reuse between the two platforms. For a larger app, of course, there's going to be situations when you need some customizations to the UI or functionality based on the platform you're using. And we also do purport this 80% code sharing with the web. What does that mean? Well, if you're already using an Angular 2 or above based web application, you can actually take the plumbing of that app and drop it in a NativeScript app and it'll just work. More on that in a little bit. And again, you can reuse popular plugins from Node, JavaScript, CocoaPods, and jars as well, Android jars. And we do have deep integration again with Angular and TypeScript. I'm going to repeat myself many times in this talk. So what is the NativeScript difference? What are our like kind of our key differentiators, or what are the things most important to us? Well, we're very focused on this idea of a rich, animated, no compromise native UI, right? We feel apps should look good, feel good, and be fun to develop at the end of the day. Along those same lines, we want to make sure that our UI performance is measurable, and we continue to measure ourselves against our competitors, right? We want to provide a 60 frame per second jank-free performance. You know, it doesn't mean anything if you go native if the app doesn't feel 100% native. And along those lines, our line of 3.3.x NativeScript releases in the last few months have been all about performance. As Todd mentioned in the keynote too, you saw the results of those. And again, we're very focused on code and skill reusability. This little video here is a good example of that. This is from Nathan Walker, who's here today. He developed an Angular 2 advanced seed project that lets you take your Angular 2-based application and repurpose that code for native iOS and native Android. So one code base, granted you are rewriting the view layer for iOS and Android, but you're sharing all that plumbing, all that code behind JavaScript. And again, for the third or fourth time, you're leveraging native libraries across these platforms. So how does NativeScript work under the covers? To me, it is mostly magic, I'll be totally honest with you. I am a developer by trade, but when it gets into like the core framework, it's just way beyond me. So I'm provided this like what I think is like a purposefully confusing slide to make me look like I know what I'm talking about. And I'm sure to some of you this maybe does make sense. But for me, when I'm looking at a new framework, it really is helpful for me to look at code. So if I were writing NativeScript compatible code for Android, it might look something like this. And I'll give you a second to kind of parse what's going on here, but we do have JavaScript code that's instantiating this Java Android text format time object, calling the set method and returning the time.format method, right? Okay, that's all right. Similar thing on iOS. This code instantiates an Objective-C UI alert view class, setting a message property, and then calling the add button with title method. And so when you run this on an iOS device, you're going to get that native alert. Okay, that's all right too. One cool thing is that these methods map directly to the UI alert view docs from Apple, so it's very easy to look up those native APIs. And it's important to remember that this code that you're writing is running directly on the VMs on the devices. So with Android, it's running on on V8. With Apple, with iOS, it's running on a modified JavaScript core. So this is all fine and good, but you should be saying to yourself, I don't want to write iOS and Android code that's JavaScript. I don't want to write JavaScript that looks like Objective-C. That's like the worst world in every way possible. So this is where the NativeScript module layer comes in. And now NativeScript modules are effectively abstractions on top of native APIs, right? It provides a unified API across platform. A good example of this is the NativeScript file module. So those 2 lines of JavaScript you see here, those map directly to the native APIs you see below. So you don't have to know what an NS file manager is. I don't want to know what it is, right? I just want to know how to access it with the NativeScript file module. So very dumbed down, this is great for me, this kind of dumbed down way of thinking about writing your code with NativeScript is you have this application code at the top, right? And 99% of the time, you're going to code against those NativeScript modules, right? Those cross-platform API abstractions. But there are the rare circumstances where you need to code directly against iOS or Android APIs. And that is where you get into writing that crazy Objective-C-ified JavaScript, right? Which is only if you need to do it, it's there. And at the end of the day, the NativeScript runtime is going to gather up all that code, regardless of how you've written it, and it's going to spit out native Android and iOS APK and IPA files, right? The native app binaries. So it's all sounds all good, right? But how do you turn this into a native app, right? Well, you put it all together with your UI is created with an XML-based markup, right? It's not HTML, but it's pretty darn similar. It's pretty easy to understand, I think, and we'll get into it in a little bit here. Of course, your backend logic is all JavaScript, and you're styling the app with CSS. Same CSS we all know and totally despise on the web. It's here in NativeScript, but it's really the best thing we have, right? And I'm going to reiterate this too as well. There is a choice in architecture, right? You can use plain vanilla JavaScript. Again, if you're a spaghetti JavaScript developer like me, you're going to be totally at home. If you're a TypeScript person, we have first-class support for TypeScript. And if you're an Angular person, you're absolutely going to feel at home with NativeScript. So let's do a little virtual hello world. Let's kind of see how things would go if we're going to start developing a new NativeScript app. First thing I'm going to do to install NativeScript is a simple npm install, npm install-g, to install it globally. I don't know why the global installation isn't just default, because you see it in every installation command ever. And then we're going to run tns create app name. TNS, what does that stand for? It stands for Telerik NativeScript, kind of holdover from our pre-progress acquisition days. So TNS create app name, then we're going to navigate into that newly created app directory. And that's going to scaffold up an application for us, a very simple vanilla JavaScript-based application. And so this is what your boilerplate app directory is going to look like after you execute TNS create. One thing I want to highlight, because I don't have time to go through all these different resources, but I do want to highlight this section in here. Now you see 3 different files that are called main page something. Now every view or every page in your app is made up of 2 or 3 files. You have an XML file, which is how your UI markup is defined. You have that code behind that associated JavaScript file to run the logic of that page, and then you optionally have a CSS file. Now in this case, this main page CSS file is only going to execute CSS for that page. The CSS you write there is only going to apply to that view. You also see there's an app.css file up at the top. That's going to apply global styling for your entire application. So you can see how you can have global styles and then individual styles for pages and so on. Now at this point, if I execute TNS run iOS, it's going to execute the app, or it's going to run the app, it's going to build the app and run it in the simulator. Same thing for Android. You see this nice little cross-platform TNS run Android. And as an aside, I do need to point out that you can leverage alternative Android emulators. So Genymotion works fine. If you're on Windows, you can use the VS Android emulator too. And by default, when I use TNS Run, it's actually going to leverage NativeScript LiveSync. I'm sure some of you have heard of LiveSync already. It's really a critical component to developing your apps. It provides this live reload, live refresh when you're developing your app. So instead of making a change, rebuilding and redeploying to a simulator or a device, which in all honesty is going to take you 30 seconds to a minute, you can make a change to your app, have it be saved, and then see those changes within a second, if not less. So obviously, when you get into that iterative development cycle, LiveSync is really critical, which is why we now made it a default part of your TNS Run experience. Okay, I'm going to break into a demo here, and hopefully I can switch mics. Can you all hear me with this? This is going to be tricky. All right. Uh-oh. There we go. Okay. I'm going to be all squatted over, all awkward for this demo. I'm a horrible live coder too, so you'll inevitably see me make some really sweet mistakes. So I'm going to open up my terminal. I'm going to try and crank this up as much as I can here. Of course, if I'm installing NativeScript for the first time, again, it's npm install -g NativeScript. Whoops. You do not want to watch me install NativeScript, right? And there's a lot of npm downloads that have to happen. That that would be a waste of everybody's time. So instead, I'm just going to run tns create. We're going to call it dev day. And you can see how quickly we can get a nice little bootstrapped app running here. It's going to install my hello world template. And it should be done right here. Awesome. So instead of actually running this, I already set up an app called Dev Day Demo. Now, the only difference with this app is that I already ran TNS Run iOS here, which just downloaded and installed all the platform-specific files. So instead of wasting your time watching those platform-specific files get downloaded, instead you can just see it working on my device. And I'm also going to warn you, I'm on like a 4-year-old laptop too, so the build is slightly slower than what you're going to see. Of course, the better hardware you have, the faster these builds are going to run. And this will run on my simulator. And let's zoom this up a little bit. That's too big. Okay. So again, we can see this out-of-the-box experience. We get this nice little demo. I can tap the button. You don't want to see what happens when I get down to 0. What I do want to show you, though, quickly is what this code looks like. And I'm going to just pop open my Dev Day demo app in Visual Studio Code. And that's reasonably sized. So if I go in here, and you can see, and we'll get into the UI elements shortly here, but you can really see how we have these very properly named elements. Here we have an action bar that corresponds to our action bar at the top. We've got a My App in there as the title. We have a stack layout, and we'll get into layouts in a little bit, but we have 3 UI elements underneath that. We have a label, a button, and another label, which correspond to these 3 elements right here. All fine and good, right? And of course, with LiveSync, we can get into like change the text, tap the button, you fool, and we can align it to the right. And we can go over here and we can see, well, you can't really see the alignment, but you get the point, where that LiveSync gives you that really quick iterative development process, which is really pretty critical. Now, the same thing applies to CSS. Now, you've seen my default CSS file. If you take out all the comments, it's really pretty simple what's going on here. We are running an import statement to bring in the core theme. Now, every NativeScript app ships with a set of core themes. By default, it's using the light theme. We can switch it to the dark theme, see how that looks. Looks pretty nice. We can do some things to our button. We can crank up the button size. We can, let's set the font color to orange. I'm sure that'll look awesome. So there we go. So really quick changes, still a totally native app, but using LiveSync, you can see how we improve our development process pretty significantly. One thing I want to show you in Visual Studio Code here is the debugging options. So if I head into my debugger menu here, and I'm going to go ahead and choose my NativeScript environment. And now I do have the NativeScript extension for Visual Studio Code installed, which is totally free. You can look it up. I'm going to launch this on iOS. Didn't I do that? Whoops. Let's try this again. So what this is going to build, this is going to do, it's going to build a debug build of my app and deploy it to my simulator, which should happen pretty quickly. And what I can do is go, while this is running, I can go back to my files here. And I can get into my, let's look at my view model. And I have this on tap method here. So why don't we just go ahead and set a breakpoint here on my counter, or when I drop that counter down one. And if I hit the tap here, okay, boom, it hits my breakpoint here. So I can start inspecting variables. I can go back to my debug window. I can set watch expressions. So I can see what this .counter is. It's 42. You know, I can do my step through debugging and such. So being able to leverage those Visual Studio Code debugging, tools are really pretty critical for us. Now, on the same thing, another thing I want to show you quickly is with Android. So I can do. Let's clear this up here. Let's say TNS debug Android. So do this manually. It's going to create an Android build, of course, or a debug build of my device for Android. It's going to go ahead and deploy it to my emulator running here. Now the cool thing you'll see is that highlighted in blue is that I'm provided a URL to open up Chrome. So I'm going to grab this URL, and this is going to use my browser-based dev tools, which is, to me, pretty amazing. So the same dev tools we've been using for years are now available to leverage debugging in NativeScript. Now, Todd went over this really briefly, and there's going to be an awesome talk tomorrow I highly suggest you go see. But using this, like Todd said, you can inspect the elements of your app, and these are real native UI elements. You can you can access the console, you can look at resources of your app. You can look at network latency issues, so if you're having a problem with a remote endpoint or problem downloading images or videos, you can do all that within the Chrome DevTools. All right. So, back here. All right, let me switch back to this guy. So, let's talk about some NativeScript core concepts. We went over everything really quickly, and I know I'm throwing a lot of information at you, but hopefully it's all fairly straightforward. But let's look at some more of the details in the NativeScript itself. As I define views with my app, of course, I'm going to be leveraging these native UI elements, right? So in this example here, I have a page element and I have a label element. Now, the cool thing about these elements is that you pretty much know what a label is, right? It's just I'm outputting some kind of text to the screen. Now, the key component here to know is that these UI elements are actually NativeScript modules, right? They're cross-platform abstractions. So, for example, when I look at a switch, in NativeScript, I just need to know it's a switch. And that's going to map to the native Android and iOS switches, whatever they're called. I don't care. I don't know. I don't want to know what they're called, right? Because it's going to be something confusing. But with NativeScript, it's very simplified. And out of the box, there's plenty of UI widgets to choose from. There's all these listed here. And remember, these native UI widgets do mean native performance, native behavior, native accessibility, all that kind of good stuff. And when we look at our NativeScript UI, or when we're mapping out our UI, let's refer back to this image. This is just a basic to-do app that you've probably seen before, and we're going to kind of break this down a little bit to see how our native UI corresponds. So if I'm throwing some NativeScript UI elements on here, at the top I'm going to have a label. It's a highly styled label with some CSS. We have a text field underneath that. We have a repeater or a list view that's binding our array of data. And we have a segmented bar for filtering. That's just what those are called in NativeScript. Now, how do I lay out these elements? How do I organize them on the screen? That's where these layouts come in. And we have a set of what I consider traditional layouts with NativeScript. There's an absolute layout, so that means assigning XY coordinates to all of our UI elements. We have a dock, which lets us assign elements to the top, bottom, left, right, or center of our screen. We have a grid, which you can think of as a table-based layout. We also have a stack layout, and this simply stacks items on top of each other or horizontally, depending on how you specify. And we have a wrap layout that simply wraps elements around each other as space is available. There's also a flexbox layout. So if you're a flexbox person on the web, you can leverage flexbox in NativeScript. And now the power of NativeScript layouts isn't necessarily in the layouts themselves, but it's more in the nesting capabilities. So in this example, we have a stack layout on the outside, right? That has that label at the top, and then it has a grid layout underneath it. So the label is stacked on top of the grid layout, and then within that grid layout, we have a table-based layout of items. So your layouts can get pretty complicated pretty quickly, which is a good thing. It lets us create really complicated UI for our users, a really gorgeous UI that is complicated in its own way. Now, as an aside, I do want to mention the platform-specific capabilities of our UI. There's a few different ways to handle platform-specific behaviors. The first is with files themselves. So I can actually name my files differently depending on which platform I want them to be viewed on. So in my example before, if I had a main page.android.xml and a main page.ios.xml, I'll give you one guess of like which files show up on which platform. Now within a single view, say I had just my main page.xml view, I can actually add markup tags to have different platform-specific capabilities exposed with these Android or iOS tags. And getting even more granular, we can have individual attributes. So in this example, which you can probably barely see, I have a label and has an Android class and an iOS class. So you can see how we can get very focused with our platform differences. And again, NativeScript is very focused on writing once by default, but allowing you to target specific platform capabilities when needed. And again, your apps are completely styled with CSS, and we know and we love CSS. It never does us wrong, right? But it is available for us, and those same naming conventions exist. This is where you're going to find yourself using most of the platform-specific capabilities, I believe, is with styling your app, because there's always little differences that you might want to see between those apps. We do support a subset of CSS. It's not 100% mapped, but it has numerous properties, and we're always adding more. And we support the same selectors you're used to using. So if you want to select all the buttons, it's just a button, right? If you want to select by class, it's the dot syntax. And if you want to select by ID, of course, it's the hash syntax. And if you're a SAS or a less person, we support those out of the box as well. Just use the TNS install function to install the SAS or less plugins. Now, when we're talking about UI, we have to talk about NativeScript UI, which again, Todd announced earlier is being made completely free. I think my little animation here didn't work. There we go. So the cool thing about NativeScript UI, you do get access to these really powerful charting capabilities. There's a data form control. It's the second one here. It's the least sexy on the screen, but it's really powerful in terms of being able to create a form on top of your data. And there's a calendar, there's a radial gauge, there's autocomplete, list drawer, or a list view and a side drawer, and probably something else I'm forgetting. So now that it's all free, you should definitely check it out. Totally worthwhile. And of course, it's all JavaScript in the back end. So our code behind, to use a Microsoft.NET term, the option is to use vanilla JavaScript. It's there for you to use. There is a built-in MVVM pattern, so if you're familiar with the MVVM pattern, it's there for you to use. Again, Angular support, TypeScript support, Vue support if you're a Vue person, completely community-driven, and we're trying to support as much as we possibly can. We want to get a 1.0 version out this year yet. And as Todd mentioned too, we do have an early look at Preact support, kind of a React alternative in the mix. And debugging strategies. There are a variety of ways to debug your app with NativeScript. You can debug by alert, which is insane, but you can do it. You can debug in the console log. You can output variables to the console log. You can debug with those developer tools that I showed you really quickly. You can use the Chrome Dev Tools, the Safari Web Inspector, whether you're on debugging for iOS or Android. You can debug by ID. We tap into the native debugger for Visual Studio and for Visual Studio Code. So there's a lot of options for you when it comes to debugging. And in terms of our DevTools support, we're trying to get perfect coverage here across all platforms, across all development environments. We're slowly but surely getting there. And again, there's a great talk tomorrow you're going to want to see for the Chrome DevTools. But you can see that we want to slowly check off those X's there when it comes to supporting the DevTools on both platforms. Really quickly, anything else? There's two easy ways to use NativeScript. There is the NativeScript CLI, and there's NativeScript Sidekick, which you heard Todd talk about earlier. In the next talk here in this room, we're going to dive into tooling a little bit more. CLI, of course, is free open source. It's certainly for those of us who are more comfortable in the command line. It does require the installation of some dependencies, which is why some people either can't or won't go that route, which is why NativeScript Sidekick was created. And while Sidekick does build on top of the CLI, it does provide you, it kind of abstracts some of those tedious features away and allows you to access those in more of a visual interface. And before I end here, I do need to shout out to the NativeScript community. They're a huge reason why we are here. And I want to reiterate, these two new NativeScript books are definitely worth checking out. The NativeScript book by the Brosteins is more for probably the vanilla JavaScript developer. And Nathan Walker and Nathaniel Anderson's book on Angular development is obviously a little more appropriate for the Angular developer. If you need support, the first place you should look is our forum at forum.nativescript.org. Community Slack, again, Todd mentioned this, it's growing all the time. If you need more of that real-time support, that's a great place to look. And if you're anything like me, you feel like this right now. So let's go to the bottom line here. NativeScript is a framework that allows you to create native mobile apps without web views, right? It is truly native UI. You're using JavaScript or TypeScript to develop your apps. You get that full access to those APIs that you need. And it is made for and made by web developers, right? We're all web developers. We want to continue using those skills. And like I've said many times, you can use Angular or not. You can reuse thousands of libraries. And these are probably the three biggest differentiators, again, when you're comparing us to other frameworks. So here's your elevator pitch. So this is what you can share with the world. So NativeScript is an open source framework for building truly native mobile apps with JavaScript. You're using your web skills like Angular and CSS, and you get that native UI and performance on iOS and Android. Anything you need can be found on nativescript.org. Thank you very much.